Hello, and welcome to a discussion of different types of current and voltage sources that can supply power to our circuits. This is actually kind of a short lesson because there's really only two things to introduce to you, the concept of a voltage source and the concept of a current source, but they are so essential to the behavior of the circuit that I felt like they deserved their own lesson. Now, I mentioned to you last time that when we're talking about a circuit, of course, the electrons are going to flow from a point where it's less desirable to a point where it's more desirable. But if we didn't do anything else, they would just quickly go to the place that was more desirable. They would make it less desirable by their presence, and then the circuit would pretty much stop doing anything special. So what we need to do then is we need to think about how can we make it so that the electrons will always have a place to go. The way that we do that is with voltage sources and current sources. So really we have two choices here. We can control exactly how much voltage will appear across 2 points in a circuit, regardless of how much current is there, or we can control exactly how much current will flow, regardless of how much voltage is there. And either one of those ideas is kind of foreign to us, that we're having complete control over one of two very important quantities, and we are completely disregarding the other one. We don't really care what the other quantity is. And so in the first case, which is a voltage source, we're saying that we will be completely specific about how much voltage appears across the two terminals, and it doesn't matter how much current is going to flow. As I write in the text there, it kind of like going on a date, and you get to choose a movie and dinner, and if your date really completely didn't care about where you ate dinner, but was very specific, the date is over if we don't go to this particular movie. And it's the same way with a voltage source. It doesn't care how much current is flowing. The current is really regardless of the voltage source, but the voltage source will have complete control over how much voltage appears. Now there are two different symbols here for the current source, or for voltage sources. You can see the one on the left is four parallel lines. The one on the right is a circle with a plus and a minus inside of it. These are really largely equivalent to each other, although the one on the left with the four parallel lines is primarily used for constant voltages, DC voltages, and in particular, it's really the main symbol that's used to represent batteries. So if you have a battery in a system, you might use the symbol on the left. If you don't have a battery, if it's plugged into a wall, or if you have a power supply of some sort, then you might use the symbol on the right. The symbol on the right, you really can't go wrong. It's used it's used in constant voltages, it's used in time varying voltages, it's used in largely any sort of voltage source that you'd like to have. One thing to notice about the symbol on the left is that the plus and minus that I've shown here are often not included. So you need to remember which is the positive terminal, which is the negative terminal. The way that I do that is I remember that the shorter bar here on the bottom, doesn't have to be on the bottom, but in this case it is, the shorter bar looks like a minus sign, and so therefore it is the negative terminal. The larger bar, you could imagine breaking that in half and putting part of it vertical. That would then look like a plus sign. So it's easy to remember that the larger bar is the positive terminal and the smaller bar is the negative terminal. So that's a voltage source. You have two different symbols, but it's really the same idea. The other option really is a current source. So you can see in figure 6 an ideal current source. And here, again, we don't care how much voltage is required. We're just constantly going to be pushing 5 amps of current. Now in this simple circuit, there's really just one path for that current to follow. And so it's important to recognize that 5 amps is going to follow the entire circuit and go back to the input of the 5 amp source. In this case, it would be sort of like the opposite, where your date would say, you can pick any movie you want, but we absolutely have to eat at this particular restaurant. And so in this case, we don't care about the voltage, we only care about the current, and we're going to apply current to the system, and by applying current to the system, we're going to add energy. We're going to keep things sort of excited and moving, and there's going to be current flowing around the system. Whether you apply a voltage source or whether you apply a current source, you're going to find that introducing those power sources into the system is the driving force behind the operation of the circuit. If you have a circuit that doesn't have either a voltage source or a current source, it's really not going to do anything. It's just going to be an inert object just sitting there waiting for you to apply a voltage or a current to it. So it's really the voltage source and the current source that's going to be the driving force behind whatever it is that you're doing.